Hey everyone, today we're going to prove that sine of 2x over cos of 2x plus 1 turns out to be equal to 10x using some manipulations on our trig identities. So first off, we're going to go from the left hand side to the right hand side. We could go either way, depending on how creative we can be, but the left hand side to me at first glance offers more to work with, and so I'm just going to choose to work with the left hand side and bring it to the right hand side. But again, you don't have to do that, it's up to you. So first off, I'll remind you guys that sine of 2x is 2 sine x cos x. So let's start by writing that out. 2 sine x cos x in our numerator. And we have 3 options for cos of 2x, right? It's really just a matter of what we either prefer or what we think might be most convenient depending on the context that we have. I'm gonna go with cos 2x is equal to, let's say, cos squared x minus sine squared x for no particular reason, honestly. Let's try cos squared x minus sine squared x. And now, just at a quick glance, that plus 1, I'll remind you that the first Pythagorean identity you most likely came across was that sine squared x plus cos squared x is equal to 1. And so that means that we can put in sine squared plus cos squared anytime we see a 1 in our expression. And so this 1 here looks suitable to be replaced by sine squared plus cos squared based on what we have tagging alongside of it, okay? So just by kind of a hunch, I'm gonna make the plus 1 become plus sine squared x plus cos squared x, okay? Again, it's just a hunch. Eventually, as you do more and more of these, your gut instincts will lead you to more efficient pathways, but it's really just a matter of practice. So now let's see what we can simplify. So we have in the numerator 2 sine x cos x all over. Now, what can we simplify down in the denominator? We have negative sine x squared x plus sine squared x. So those will cancel each other out. And now what we have left is, that is cos squared x. Now we have cos squared x plus another cos squared x. And so 2 cos squared x. And now you might see how this simplifies down to the right hand side. The 2's cancel each other out. The cos x on top cancels the squared factor on the cos x at the bottom. And so right away we end up with sine x over cos x, which we know is exactly 10x. Now, if we want to be precise, we could also state our non-permissible values, our NPVs here on the side, if you're so inclined to do so. So, remind ourselves that we can't have a denominator of 0, so that means that cos 2x plus 1 can't be equal to 0, and doing a bit of algebra leads us to cos 2x can't be equal to negative 1, which means that 2x can't be equal to the inverse cos of negative 1, which means that 2x can't be equal to the inverse cos of negative 1. Cos is our x coordinate, so that's going to be negative 1 pi radians, and so 2x can be equal to pi, and that'll be true for every integer revolution afterwards or before. So plus or minus 2 pi k, k being any whole number because we have positive or negative revolutions around the unit circle. And now we still have one less of algebra. We're going to divide by 2, and so we divide each part by 2. An important little note here. And so we have ultimately that x can't be equal to pi over 2 plus or minus pi k, where k can be any whole number. And we also can't have cos x being 0, because we remind ourselves that tan x is sine x over cos x, and so we also can't have cos of x being 0, which means x can't be equal to the inverse cos of 0, which means x also can't be, again, cos is our x coordinate on the unit circle, so that's at pi over 2, and 3 pi over 2, and 5 pi over 2, and 7 pi over 2. So pi over 2 plus or minus any integer multiple of pi revolutions, every half revolution around the circle. And so that'll be pi over 2 plus or minus pi k, again, being any element of the set of whole numbers. And so here are all of our non-permissible values for this identity, this equation, alongside the proof that they are, in fact, the two sides are in fact equal to one another. So I hope this helps out with statistical connections, and thanks for watching.